Okay, I want you to imagine a problem, a single mathematical question that is so profound, so incredibly difficult that it's managed to resist every single attempt to answer it. A puzzle that has stayed completely unsolved for generations. And this isn't just some dusty old thought experiment. This problem is so important that back in the year 2000, a $1 million prize was put on the table for its solution. But you know what? This story isn't really about the money. It's about a challenge that has stared back, completely unanswered, at the world's most brilliant thinkers. A riddle that has just endured for over 160 years. Think about that. It stood like a monument to the very limits of what we know. Solving this wouldn't just win you a prize, it would literally change the foundations of mathematics as we know it. Okay, let's dive right in. This is the story of the Riemann Hypothesis. And let me tell you, this is widely considered the single most important unsolved problem in all of mathematics. Period. I mean, just look at this timeline. It really puts the sheer scale of this mystery into perspective. It was first dreamed up way back in 1859 by Bernard Riemann. By 1900, it was already so legendary that David Hilbert called it one of the most essential challenges for the entire 20th century. And then 100 years later, it was enshrined again as a Millennium Prize problem for the 21st. We're talking 3 centuries, all focused on one single unsolved problem. So, to really wrap our heads around this thing, we've got to start with something we all learn in school: prime numbers. They seem so simple, but trust me, they are the key to everything here. So here's the crucial point. Prime numbers are the fundamental atoms of arithmetic. Every other whole number, I mean every single one, can be built just by multiplying primes together. But when you try to list them out, they seem to follow no rule at all. It's like they're scattered along the number line in total, unpredictable chaos. And this is the question that haunted mathematicians for centuries. What if all of that randomness was just an illusion? What if, hiding just beneath the surface, there was a secret pattern, a deep, universal law that was secretly pulling the strings? Well, Bernhard Riemann was absolutely convinced there was a hidden order. And to find it, he created this incredible tool. You can think of it like a mathematical map. It's called the Riemann zeta function. Now, this is where things get a little abstract, but just stick with me, okay? This function is like a special kind of lens. It takes the prime numbers, which live on a simple one-dimensional line, and it projects them onto this richer, two-dimensional landscape. It's kind of like turning a flat, simple melody into a complex, beautiful symphony. And by seeing the primes in this whole new dimension, Riemann could suddenly spot patterns that nobody else had ever seen before. And this function has this really weird property. There are specific spots where its value just drops to 0. Now, some of these zeros are super easy to find. They're predictable and honestly not that interesting. We call those the trivial zeros. But then there's another set, the non-trivial zeros, and these are incredibly mysterious. They're the ones that hold the secret to the primes. And Riemann discovered they weren't random at all. They were all packed together in a very specific place. And this is it. This is the whole thing. This is the Riemann hypothesis. When you look at the chaotic mess of prime numbers through this special zeta function, they suddenly reveal this breathtakingly simple order. The hypothesis claims that all those important, mysterious, non-trivial zeros fall on one single, perfectly straight vertical line, each one perfectly aligned with all the others. And the evidence is it's overwhelming. Using massive supercomputers, mathematicians have found and located the first 10 trillion of these non-trivial zeros. And every single one of them, without a single exception, lands perfectly on that line, exactly where Riemann said it would be. But this right here is the heart and soul of mathematics. 10 trillion confirmations aren't enough, not even close. Because what if the 10 trillion and first zero is off the line? Or the googolplex is 0? Until someone can prove with absolute, undeniable logic that every single zero has to be on that line, the hypothesis remains just that. A hypothesis. Unsolved. So why the obsession? Why the $1 million prize? Because proving this isn't just about finding dots on a graph. Its truth would lock in our understanding of numbers and send massive ripple effects across science and technology. If the hypothesis is true, we could predict where prime numbers show up with absolutely astonishing precision. But it gets even crazier. The pattern of these zeros seems to perfectly mirror the behavior of energy levels in quantum physics, building this bizarre, mysterious bridge between pure math and the physical universe. And, of course, because prime numbers are the backbone of modern encryption, it has huge implications for the digital security that basically runs our entire world. Now, you've probably heard this idea that a proof could somehow break the internet. Well, that's a bit of an oversimplification. While it would have really deep implications for the field of cryptography, the algorithms we use today depend on finding the specific prime factors of a huge number. As this quote points out, proving the hypothesis doesn't magically give you a key to do that. So, the internet is probably safe. So, just how hard is this problem really? Well, to get a sense of that, we need to see where it sits in the grand landscape of mathematics. Back in 2000, the Clay Institute basically put out a most wanted list for mathematics, the 7 Millennium Prize problems. These are considered the absolute hardest, most fundamental open questions that exist. And yeah, the Riemann hypothesis is right there on the list. And this single fact, this should tell you everything you need to know. Of these 7 monumental problems, in more than 2 decades, only one, the Poincare conjecture, has ever been solved. It was cracked by the brilliant and famously reclusive Grigori Perelman. The other 6, including Riemann's, are still completely out of reach. So you see, this is so much more than just another math problem. It's a challenge that has pushed the absolute boundaries of our tools and our imagination for more than a century and a half. To solve it, you literally have to go where no one has gone before. And in the end, this whole quest reminds us of a really beautiful truth. Sometimes the simplest things, the basic numbers we learn about as kids, can hold the most profound and incredible mysteries. Proving the Riemann hypothesis would finally let us hear the hidden music of the primes. But it really makes you wonder, doesn't it? What other cosmic secrets are out there, just waiting for us to find them, hidden in plain sight, in the simple patterns of the numbers that are all around us?